Finally, we talk about stability. This is really one of the rules of the game, but it's much easier to talk about in the context of the real algorithms that we've seen so far. And really, it doesn't make sense if you don't know about comparators, which we just introduced. So the typical application that I just used as an example is, say, this set of student records. So we have them sorted by name. This is, say, something that we do just before assigning final grades. Maybe the third line there is the final grade. So it's all fine, it's sorted by name, but then in order to distribute it out to the people leading each of the sections, what we want to do is sort by the second field, sort by section. The problem is that when we do that, it messes up the sort by name. And that's annoying. You might assume that once you have it sorted by name, that when you sort it by the second field, then it should maintain the sort of by name for all that have equal keys in that second field. Actually, not all sorts preserve that property. That's called stability. And clearly, it's worthwhile to think about, for your application, whether you want or need a stable sort. It's an annoying surprise for many people in many applications. So a stable sort is a sort that preserves the relative order of items with equal keys. Which of our sorts are stable? That's an interesting question that we'll take a look at now. The quick bottom line is that insertion sort and merge sort are stable, but not selection sort or shell sort. And even within that bottom line, there's implementations that maybe are not stable. You have to carefully check the code to be sure. Always in this class, we have an exercise or exam question. Is this version of this sort stable or not? So students learn to recognize whether code is stable. So this is just another typical example where we've got things sorted by time. And then what we want to do is maybe these are important events, people buying tickets to a rock concert. And then we want to sort by location. What we'd hope is that it would keep the sort by time, but this is a non-stable sort that doesn't do that. So then out in the locations, they're going to have to resort it if they use one of these. But if they use a stable sort, then it stays sorted by time. Lots of applications you want stability. All right, so let's just look at each of the algorithms that we've considered so far. Insertion sort. Insertion sort is stable. Why is it stable? Well, we never move equal items past one another. In this example here, when we get A1, well, that's, so in this case, the index is just when it appears in the array, it's just A's and B's. When we get our second A, we stop the sort as long as we're not less. We're equal, we're not less, we stop it. So we never move an equal item past another one. If this less were less than or equal, then it wouldn't work. Or if we did it the other way around and it proceeded accordingly. So equal items never move past each other in this code, so therefore insertion sort is stable. But selection sort is not stable. Usually the way to show that a sort is not stable is just to see if it has a long distance exchange that might move an item past some equal item. So in this case, for example, for selection sort, when we do that first exchange, where we found the minimum A and B is in position 0, we did a long distance exchange. And that catapulted that first item past any item that it might be equal, putting them out of order. And that may not get fixed, so that sort is not stable. It might move items past some equal item and leave a result where items that are equal are in different order than they were originally in the file. Selection sort is not stable. Shell sort also has long distance exchanges, so it's not stable. It moves keys past other keys that could be equal. And so it's easy to construct examples showing that selection sort is not stable. And what about merge sort? Merge sort is stable. Well, it's stable as long as the merge operation is stable, and that operation is going to be stable depending on how we code it. And in our code, if the two keys are equal, it takes from the left subarray. So that means that it'll always take the, if there's two sets of equal keys, it'll preserve the relative order. And that's enough to show that the merge operation is stable, and then therefore merge sort is stable. Stability is an important property in sorting algorithms. Merge sort is not only efficient, it's also stable.